Okay guys, so today I'm going to be talking about snare exciters. As you can see, I've already got one set up here on the workbench. This is one I made earlier on in the week. I was planning it a while ago really. I spoke to a guy called ABRAMS LaB. I'll post a link to his videos in the description, and he gave me a few tips and ideas and basically the dimensions that makes a pretty decent snare exciter really. As I already had the secondary form and I wanted just to wind it just to see how it came out. So I asked him, he said, yeah, use 30 AWG wire, about 800 turns thereabouts, 6 turns of the 1mm tri-rated around the bottom there. Doesn't have to be tri-rated, but that's what I had for the primary, and a 150mm diameter sphere for the top there. That's brushed stainless, guys, so it's a pretty nice sphere. And a tip 42C switching transistor, which you can just about see under there on that heatsink there. I've also added above that on the heatsink, you can't quite see it properly, a little thermal cutout just in case it gets a little bit too warm. It'll switch off pretty quickly. And yeah, I know you're not supposed to really put things inside the bottom of the coil, but I thought, it doesn't matter for a small little snare exciter, so yeah. Seems an ideal place to stick that circuit. There's only a few things on there anyway. There's two 1N 4002 fast switching diodes, a 47k ohm resistor, obviously the tip 42, and I had a couple of connectors hanging around, so I connected it up with those, and that was about it, other than the thermal cutout I stuck in there as an extra, just for safety. It means I'd have to fry loads and loads of tip 42s, so it's quite handy. So yeah, so it came out pretty cool, and I'll show you it working now, guys. So if I just switch the lights over, there we go. Alright, so I'm running it off the power supply, which is probably not a brilliant idea for something like this, but it is quite a distance away, and it only runs at 6 watts, I think it was. So the power is quite small, so we'll just run it off of this so you can actually see the power consumption of it. So okay, switch it on. It's getting a little bit loud, this, guys. I need to change the fan in it, or at least clean it out or something. It's starting to drone a bit. So I'll crank up the volts. Runs at about 12 volts usually, this one. You can run a little bit high. I think ABRAMS, he uses 14 quite often, but I think for this one 12 seems just right. So you go about 12. It's pulling just over half an amp. It's gone up since the other day. It might be the position of the primary coil, depending on where you stick it. So that is running now, guys, and yeah, you've noticed it's not doing a lot because it's a snare exciter. They don't generally do a lot. I could probably make a little breakout. I put a little cone on the top of the sphere there, but it probably won't do very much. It might just like have a tiny little bit of a arc or a bit of corona around the top of it, but I haven't tried that yet. But yeah, one way to prove that it does do something is obviously to put a little fluorescent by it. So there you go. That's lighting up the fluorescent tube. It's only a small little, what is it, an 8 watt? Yeah, it's a little 8 watt emergency light fluorescent tube. Lighting it pretty well. You'll notice the amps go up when the tube's closer to it, so that's nearly touching it. The amps go up. When you take it away, the amps go down. Also the volts come up a little bit. When you take it away, put it back again, volts go down a bit. So yeah, that's just a pretty cool effect. So yeah, it runs that one pretty well. Also got a one of those UV ones, little 2-foot UVC, so yeah, I'm getting a sunburn off that, so I'll put that back now. And also noticed it runs neons quite well. I've got a neon lamp here, a little beehive one, it's already running it at this distance. So yeah, that's pretty cool. That runs pretty well. You can even sit it on top if I'm careful, and it'll dance. It'll dance. There you go. The way you put your hands, you disturb the magnetic field around it. But yeah, it does actually dance that, which is quite cool. Take that down, I don't want to drop that. That's quite a nice lamp to drop. Also, I notice it runs Geisler tubes pretty handy. So I've got a little Geisler tube here. If you put that somewhere near, That lights up the little geyser tube. As you can see the little green bit in the middle, that's uranium glass, even not glass. It is green. So yeah, halfway there. So that actually runs geyser tubes wirelessly, which is very handy because it means I can just put them somewhere near. I don't have to make connections all the time to try and run things. And I haven't noticed it overheat because usually you run these off inverters for what is it? Cold cathode lamps, and they run pretty well, except for they start getting a bit warm, these geysers. So running it off this is great because it runs not maximum brightness, but just enough to see it work, and it doesn't get hot, as far as I noticed anyway. Again, runs the amps up a tiny bit, and the volts down a bit. So yeah, cool. It's very handy. Yeah, so careful. Do not want to break that. And also it'll run the big 6 foot. I would have an 8 foot, but I don't have one at the moment as they're at work. An 8 foot, I'll get hold of one of those. But there you go, there's a 6 foot running. Yeah. So that's pretty cool, that runs pretty well. Nice. Pretty impressive. Just trying to break that, I'll just put that back. So yeah, pretty cool. What I'll do now, guys, I'll show you, because I've got a kilovolt meter here. I can show you the voltage that this is outputting, so I can give you guys an idea of what putting 12 volts in can actually get you out of this, just by making a little snare exciter. Because you can just run it, you can use it as basically, what I'm going to use it as is a high voltage power supply, basically, to do mostly what I just did there. And if you ever weird and wonderful experiments, hopefully. So yeah, what I'll do is I'll just turn this off, and we'll attach the probe for the kilovolt meter, and we'll see what it's actually running at voltage wise. Just by putting 12 volts in, we should get a decent voltage out. So just attach that to the top. So I'm just using that bit of tungsten there just to make a connection, because it's actually quite difficult otherwise without actually holding it, which I don't really want to do. Right, so we'll turn around, crank it back up, and I'll show you guys the kilovolt meter as I turn it up. So yeah, going through 1 volt, 2 volt, 5, 9, and 12. So about 12 volts, it's putting out about 3 kV. Yeah, just over 3 kV, which is quite a healthy voltage there. So hence why it runs those tubes and things quite well, because of the voltage on the top there. Although it's incredibly low power, you can actually literally just, you know, it doesn't really do very much. It's just get a little spark, little arc on the end of your finger. Probably don't want to hold it there too long, because you get one of those little black dots on the end of your finger where you burnt your skin a little bit on the surface. But yeah, there's not much power there, but 3 kV, there you go, guys. Hey. So they're pretty safe, really. I can't think what you could really do bad with one of these kind of things. So yeah, pretty cool. Nice little 3 kV power supply now, without overheating anything, and it looks pretty cool. So yeah, I think that's everything, guys. Oh, I'll tell you something though. I'll tell you something. I'm not really supposed to do this, but I was trying it earlier and it didn't work quite well. But I have an oscilloscope there, and I know you're not really supposed to run oscilloscopes too closely to these. You're actually supposed to unplug it. But I was using this earlier, not too close, but just about this kind of distance away. So you'll see the frequency. There you go, there's a frequency output. Nice sine wave there. Let's increase the there you go, real nice clean sine wave there. No harmonics or anything on there. It's beautiful, beautiful sine wave. So that is literally just coming from that little probe I just got floating about that far away from the Tesla, well, the Slayer exciter there. And that is giving me that frequency, and we can prove it's that frequency because I can turn the voltage down on the Slayer exciter, and you'll see the intensity, the amplitude of the sine go right down to about flat. There you go. Turn it back up again. Back up to 12, we'll take it. It's about there, 12 volts. There you go, you got a nice little output from that. So yeah, that's pretty cool. I'm yet to work out what that actual frequency is. I've got to count the divisions and work it out. But yeah, that's nice. That is nice. Cool. So I won't be running that too long, but yeah, it is output on the oscilloscope there, which is pretty cool. So yeah, awesome. Hope you guys like the video, and we'll hopefully see some more of this kind of stuff in the future, guys. Maybe some bigger stuff, you know, because this is pretty small for a Tesla coil, really. But yeah, that'll be pretty cool. And hope you guys all enjoyed, and I'll see you again soon. Cheers, guys.